Hi guys, I thought I'd give you a video demonstration of how we can do the simple regression assignment. If you're in your own repository, if you haven't already, you want to fork this assignment repository to create a copy on your own GitHub account, and then you can download these files to your computer by going to code and download zip, and then extracting that when it downloads. And I've already done that, and here are the files for this assignment. You want to open up the answer sheet that has all the instructions of what you're going to do on this assignment. Probably close that copy. So as some background, I have listed some things that you might want to think about when doing a real analysis. We're not going to look at much of this as this assignment, but I like to keep it here to have you think a little bit about what you should be thinking about when you're analyzing data. So there's not much that we're going to look at here. I'm going to kind of gloss over this, and you can read through it or watch previous assignments where I describe this in a little more detail. Data set information. So we want to look and see what data are in the variables, or what data are in the variables. So we're going to open up this sales data set in Jamovi. So if I go to Jamovi, you would open this by going to the File menu, Open, Browse, and finding the folder, and we would pick this save file, and I already have this open here in my on my computer, so I won't open that again. So we're going to look at these variables. We have one called advertising, one called sales, one called airplay, one called image. Okay, you can see a description of the variables in the data set in the field text chapters 9.2 and section 9.2.2. So let's go ahead and take a look at our variables in the data set. We can kind of skim through this and see we don't seem to have much missing data, but when we have a lot of data like this, it's a good idea to get some descriptive statistics. So this advertising budget in thousands, that's a ratio level of measurement, so continuous is the correct setting for that. Sales, this is album sales in thousands, again that's a ratio level of measurement, so continuous is the correct setting for that. Airplay is the number of plays on the radio, that is continuous, and a ratio would be the correct level of measurement, so that would be continuous. And image, the band image rating 1 to 10. Normally I would call this ordinal level data, but the way he's used it in this, he used it as continuous, so we're going to go ahead and stick with that. But just be aware in other contexts in this class, if it only has 10 categories, then I would probably call this ordinal level data and treat it that way. So okay, to get descriptive statistics for these, we're going to go to analysis and exploration and descriptives, and we're going to treat all of these as continuous so we can get descriptives for them all at the same time. Go ahead and leave the mean and standard deviation checked. We can go ahead and look at skewness and kurtosis, and a normality test, which is the Shapiro-Wilk for here. And we can look at a plot. We're going to get a histogram and a box plot. And just taking a look at this, we can see we have 200 observations in each variable, no missing data. We have means and standard deviations. On adverts, you can see that the standard deviation is pretty spread apart. Sales, not as spread apart as adverts, but still a fairly decent size. Airplay, also a pretty wide standard deviation compared to the mean, and image is a little more clustered. So I think that was a scale of 1 to 10, and you can see that they're a little more concentrated around the mean. That's not very high. Skewness. Skewness divided by standard error, that's going to be greater than 2. So adverts we're expecting to be positively skewed. And sales, skewness divided by standard error is not greater than 2, so we don't expect to see a lot of skew in that one. Airplay, same thing, probably not a lot of skew. And image, negative 1.29 divided by 0.17, that's going to be greater than 2, and that's going to be negative, so we're going to expect to see that skewed in the negative direction. And as we can see, adverts has a significant Shapiro-Wilk. Sales does, not to the same degree though. Airplay, not significant, so that one's probably pretty close to normally distributed. And image, also significantly different than normal. So not surprising, here's adverts with a positive skew. We see a couple outliers in there. Sales, fairly normally distributed, no outliers. Airplay, that looks pretty close to normally distributed. And image, we can see that we definitely have some outliers on the low side there, a couple of them. All right, let's see what else we needed to look at with our instruction sheet. So data accuracy, I don't think we have any issues that we need to address here. No additional manipulation at this time. No missing data. We had a couple outliers on some of those variables, but we're not going to change anything. We would need to go double check some data, and we don't have anything to double check with this example data set. So we do have our descriptives, so that's good enough. Now we're going to look at some test information on simple regression. We are going to use this, and I had this in the instructions. I don't think we're going to use the Bayesian. You don't need to install this if you did. I didn't realize that I'd put this down here, so we definitely need StatCat and scatter. So we're going to look at StatCat and let it help us decide on a statistical test. There's many resources, but this is something that's included in Jamovi, so it's nice to look at and nice to learn how to find a test when we know our levels of measurement. So we're going to go into StatCat. Get it back into Jamovi first. Go into StatCat, relationships, and we're just going to use two of these continuous variables, adverts and sales, and you'll see that we have a Pearson correlation, but it also tells us we can use linear regression, so that's what we're interested in here. When conducting analyses that focus on relationships, we want to get scatter plots. So let's go ahead and get scatter plots for these variables. So we can go into Jamovi, Analyses, Exploration, Scatter plots, and let's get adverts and sales and put a line in there. And then we can go to Analysis, Exploration, Scatter plot, and get adverts and airplay with the regression line, analyses, exploration, scatter plot, adverts, and image with the regression line, and as you can see, when you have a lot of variables, it gets a little tedious to do one scatter plot at a time. So you can actually get all your scatter plots by going to the regression and correlation matrix, and we can put all of our variables into a correlation matrix, and let's go ahead and get the plot for that, and let's have a flag significant correlations. So you can see that going to the correlation matrix lets us see these a little bit better. You can also see these regression lines. Adverts and sales seem to have a pretty strong relationship with each other. Adverts and image quite a bit less so, and we can look at that. Okay. We want to look at assumptions for our statistical test. Do the data meet those assumptions? So the variables that we're going to use in our simple regression, are they both continuous? And we did look, and all of our variables are continuous, so we will meet that assumption. Additivity and linearity, you can see this quite easily using your scatter matrix, and you don't see any obvious curvilinear relationships here, so we can tell that these all seem to be fairly linearly related. Homoscedasticity, roughly equal variances. We may be getting into some issues. This sales and airplay looks like it meets that assumption. You'll see at the low end of sales that the spread around the line is fairly similar to the high end, but here with adverts and sales, you'll see there's quite a bit of variability in sales at the low end, and not a lot of variability around in sales with a higher end of adverts. So this one may have some issues, but we do have a fairly large sample size, so we should be okay. Independence of observations. This is partially known by your study design. We know we weren't measuring the same individuals at multiple time points, and there was no obvious relationships between the individuals that we know of, so we should have independent observations. And I don't think we have any extreme outliers here. We're not going to worry too much about that for this analysis. Okay, the steps of null hypothesis significance testing. We're going to go through these. So when we did our correlation before, we did a couple of variables, and we were looking at a null and alternative for a correlation that there was no relationship would be the null, and there was a relationship for the alternative. Regression gets a little more complicated. Not only are we looking at the strength and direction of a relationship, but we're actually looking for an intercept in that relationship, so we can actually do some prediction. If we have the value of one variable, we can look at another, and regression allows us to actually run some hypothesis tests on some different parts of this. We run it on the model overall, and we can run it on the parts of the model, and those would be with the intercept and the model slope. So there's actually going to be a null and alternative for each of those. For the model overall, we would have a null hypothesis that the predictor is not a good, does not have a significant relationship, or the model overall, I'm sorry, I misspoke. The model overall is not a significant predictor, and the alternative would be that it is a significant, it is a good model. The alternative, or the null and alternative for the intercept, is that the null is that the intercept is not significantly different than 0, and the alternative would be that the intercept is significantly different than 0, And with the null and alternative for the model slope, the null would be that the slope is not different than 0, and the alternative would be that it is different than 0. Our criteria for rejection, we're going to usually just use alpha equal 0.05. So for all of those tests, we would have that same thing for class purposes, but there are times when you might choose a different alpha, but we're not going to get into that with this example right now. Now we're going to go ahead and calculate our test statistics, and we're going to do that in Jamovi. So in Jamovi, we're going to go to Analyses, Regression, and we want a linear regression. And we're going to calculate adverts to predict sales. So our outcome variable is sales. So we're going to take sales and put that into our dependent variable, and we're going to use adverts as our predictor and put that in our covariate. And we don't need to do anything with reference levels or model builder. Into assumption checks, we can go ahead and get a normality test. We're going to talk more about these later, so we won't worry about them too much. Let's see if I asked you to get anything in the instructions. Sales, adverts, assumption checks, check Shapiro-Wilk, QQ plot, and residual plot. Okay, we'll go ahead and do that. QQ plot and residual plot. And we're going to get model fit R squared, adjusted R squared, F test. So we're going to go into model fit, R squared, adjusted R squared, and F test. And did they ask for anything else? Model coefficients, ANOVA test, confidence interval, standardized estimates, and confidence interval. So model coefficients, ANOVA test, standardized estimate, confidence interval. And this is actually new to me this year. Looks like they have added some extra options here. And that'll be handy, so I might have to look at that a little more closely. Let's go ahead and check all three of these and see what happens. Okay, so let's see what I'm going to ask you to look for. Okay, so we're going to look for some values in here. We're going to look at some overall fit of the model, R squared, percent of variance in the outcomes explained by the model, F, P, and is the model prediction of sales better than the mean value for sales? Okay, so our model fit measures. So here's where we're going to get R and R squared and adjusted R squared. This we're going to talk a little more about later when we get into multiple regression, but something to realize or understand is that the more predictors we have, this value for R squared can get a little bit inflated, and so this adjusted R squared will adjust for the number of predictors in the model. Here you can see that they're really darn close to each other, 0.335 and 0.331, and later when we do multiple regression we'll see that there's a bigger difference in here. And we have an F value of 99.6, and we can see that this P value is significant. So that's going to tell us that this model is a significantly better predictor than a model with just the intercept in it. Something to understand is the coefficient of determination here, which is our R squared. And what that is that explains the amount of variance in our dependent variable explained by our predictor variables. And in this case, we only have one. So this is the amount of variance in our sales, which is explained by our advertising. And this is a percentage, so this is going to be 33.5% of our sales is explained by how much we spent on advertising. We do get an overall, I'm not going to have you look at too much more, but we do have an overall test here. This is pretty much the same as this overall model test here. And then we can get down to our model coefficients. So here we have our intercept, and here's our intercept of 134.14. And we can see that this is a significant predictor, meaning that this is significantly different than 0. And we do get a confidence interval for this. We're 95% confident that the true value of our intercept lies between 119.3 and 149. For adverts, we can see that our estimate for our slope is 0.09. And we can also see that this is significant, so we know that the slope on adverts is significantly different than 0. And you can see by our confidence interval that does not contain the value of 0. So this is a significant predictor of sales. We can get some assumption checks. So we see our Shapiro-Wilk is not significant, so we are not significantly different than normal. Our QQ plot is another way we can visualize that, and we see towards the tails we do go off of our normal distribution a bit, but for the most part it is pretty good. And there's our residual plots. We'll talk more about these later on, but it's good to get used to checking those. And more with sales, we'll talk more about these later. And I'm going to go back to data, and yeah, this is something new that other programs like SPSS have had the ability to do, and we can save some of this information about predicted values and residuals and Cook's distance, and we will talk more later about what that is. That's a pretty exciting development. This adds a lot of functionality to Jamovi. So we'll look at that a little down the road. So we can create a prediction equation now from this regression data, and we can predict how much we have in sales by our advertising. And so we would do that by looking at our model coefficients. So what we would say is that our predicted sales is going to be equal to the intercept, which is going to be 134.14. I just round that to 1 or 2 decimal places. Even 134.1 is probably sufficient. And so that's going to be equal to the intercept plus the slope times the amount of sales. So if we knew the amount of sales, so that would be 0.096 times the value that we spent on sales, and that would let us predict our, or the amount we spent on advertising, that would let us predict our sales. So the predicted amount of sales would be equal to 134.1 times 0.096 plus, I'm saying that wrong. Okay, the predicted sales would be equal to 134.1 plus 0.096 times the amount of sales. That would be our prediction equation. We are going to look at, we're going to save this Jamovi file and the output. So we're going to go to save the file. We would go into File, Save As, Browse, and in our folder, we're in our correct folder, we can leave that as album sales. That works just fine. And to save our output, we're going to right click in the white space of our output window, go to All, Export, Browse, make sure we're in our correct folder, and give that a name and save it. And then in our instructions, we're going to open our markdown file in RStudio. So we can go back to our folder and click on our markdown file and go open with, and we've got RStudio selected. Click OK. Give this a second to open. We have the packages we're going to use. We can run these blocks, make sure that our packages are installed, and they are, and we can use the library function to load them all into memory so we can use them. And I don't think, this did not switch over to my other working directory, so I'm going to go to Sessions, Set Working Directory, Choose Directory, and we're going to go to Downloads, and I'm looking for Simple Regression. And hit open. Okay, so that changed that to the right directory. We're going to open our album sales file, so we can run that one, and that now should be in our dataset variable. We can see our sales right there. I'm going to close some of these other windows down that I had open. Probably too many. All right. So we're going to, we can get our code from our Jamovi output. So let's take a quick look at that since I have it in the assignment. So we're going to go to Jamovi, and we're going to click on these three little vertical dots on the right hand side, and in results we're going to click that on syntax mode and close that, and we can see now we have our Jamovi syntax for getting these descriptives, and well, that was our statcat example. Looks like that's part of there's our scatter plots, syntax, correlation matrix, and here's our linear regression. So you see this is using the Jamovi package, the linreg function, and there's our settings there. And what else do we have in RStudio? Okay, so we're going to talk a little bit about the LM function in R. You can use that for a number of functions, and we're going to do this simple regression using the LM function. If you're looking at R code, you'll probably see this used a good bit. So I did put in how to do a ggplot to get a plot of our two variables, adverts and sales, and you'll see there's our plot. here's the linear model function. You can see it has sales predicted by adverts, and where our data set is. So we're going to run that, and that does give us an intercept and slope, and we can get some more information in R using the summary model. And here's our residuals, here's our coefficients, intercept, and slope that we looked at before. And you should notice that if I see if I can open these up kind of next to each other. I'm going to go ahead and turn off this syntax, and you can see that our intercept 134.1399, and we have 1.34 times to the exponent of 2. So that would move that decimal place over 2. So that is the same number, but it definitely is a little harder to read on this R output. So Jamovi does make this a little bit easier for us. And this is 9.62 with an exponent to the negative 2, and that would move that exponent to the left 2 spaces. So we can see that that's the same number also. A little more challenging to read here on this R output. The nicer formatted output's a little nicer to read. Standardized residuals. We didn't get any standardized residuals here, so we can calculate these separately. And I don't think I looked at my standardized residuals. Oh, there's our standardized estimate that I was looking for, 0.578. So that is very similar to a z-score, and we'll talk more about that later too. And it looks like I did include some our function in Jamovi compared to the linear model function, and let that run for a second, and you can see Jamovi gives us output similar to what we got in the output from when we ran it in Jamovi, but a little easier to read with this output here. So I know that's a lot. Regression gives us a lot of information. We're going to be talking more about this as we go, so this is just kind of an introduction to some of the things we can do with regression and some introduction to it. You do want to save your file. We're going to knit this to Markdown. So we'll let that run. Okay, that knit. And last thing you want to do is go to your folder, and you want to upload your files, your assignment files. So you're going to go to your repository and upload files. And then you can put your .md markdown file over, your sales output PDF file over, and your Jamovi dataset and output over, and then you'll go down and hit commit changes, and then copy the address for your repository and turn that into Canvas. All right, I hope that's helpful in completing this assignment, and I hope you have a good rest of your week.